Particles.
Particles are things like electrons, protons, or even atoms.
Let me just stop you right there, big guy. Okay, so you have all of these wonderful teaching aids behind you. I know you're going to use a baseball. I know it. I know you're going to use a baseball. You're going to do it. I know it. Look at it. I know. Yeah, I saw one just a second ago. Anyways, you have a rock. Pick that thing up. That is a particle. It's in the same way this light bath. A light is hitting this bush right here, which is also made of atoms, which is also kind of like a rock. And ideally speaking, it works not exactly round, but if you looked at this from the top perspective, or what you could do angularly, those are like quarks, really. You know, they're not really your spin, but it's a way that your CT paradox, if momentum is moving in one direction, then that bush really only has momentum relative to the particle bath that hits it from the south and east-west side, right? Because to the plant, whatever way it was grown, started genetically, atom, baseball, FMA, parked it here, has a light bath over days of bandwidths, right? So it's not just that there's a particle, but there's also that CT paradox to that particle about how it's affecting E0 to E1 in cycles with highs and lows. See, when you condense the universe about that bush, what I could tell you in an experiment, replicated the scenario, made a light cone experiment out of it with just some LEDs, and I would find out that, well, that's total growth conditions, because I wouldn't know how much water it really uses. Seems like it would have an abundancy parked right there. But in the system, that might be conditional as well. So that's a plus and a minus. That gives me the length of a stick with the length of a smaller stick underneath it, or I'm kind of parting that off to say roughly in that area, so A plus B stuff, which, you know, it'll come up inside of there. Pretty basic mechanics, really, when you think about it, but ball wave, right? So.
And particles spin. It's hard to think of something infinitesimally small.
You get it?
Spinning.
Good. Remember that, Bush.
But if you like, the analogy of a
I
baseball,
knew it! I knew there was a baseball.
Spinning serves pretty well
Could have
for
just picked up a
most
rock
of our
and threw it at that
purposes
bush.
today. There is a bunch of nuance when it comes to how that analogy falls apart, and we'll get to that eventually. But suffice it to say for now,
in the same way,
we have a tiny little thing,
I
and
threw
it's
the ball.
spinning.
Sun gets up in the morning and throws light.
And that axis points out a direction. That's the orientation, if you like.
So that's why those particles do that. So we don't do that. We trick it. We go, all right, I get that, boss. Zero, right? You're absolutely right. Now let's get to the next one.
Also, a magnetic
deal
field
with it.
associated to that spin.